Hey everyone, in this video we're going to begin working on the blueprint logic for turning in place in our distance matching animation system. Specifically, we're going to be fixing the weird rotation to facing forward when the character stops. We're going to keep the character from rotating with the camera when the character is standing still by rotating the root bone in the opposite direction of the camera's rotation while the character has stopped. Let's get into it. If we run around with the character in the current state and stop, our character rotates to face our camera direction. Like we're going right, we stop, and we go back into an idle pose. And that's a bit of an issue. And so the first thing we're going to do is fix that. And so if we stop and we're orientation warped, I want that pose to be orientation warped as well. And the reason that the character spins back around is because we are basing our orientation warping cardinal direction integer on our direction, and our direction is set to 0 when we're not moving. So we want a way to save our direction, and when we are not moving, use our save direction from the last tick. And we're going to do that by creating a new variable called direction last tick. This variable is a float just like direction is. Now we're going to come in before direction. We're going to set direction last tick to direction. So let's say for a tick, let's say we're on tick number 1. Direction is 0. Okay, direction is 0. We're setting direction last tick to 0, and we're setting direction to 0. That's fine. This is our first tick, so direction last tick and direction are going to be the same. But for our second tick, let's say direction is 1. Okay, so direction is 1, but we haven't calculated direction yet. But it's still 1 for this time period, according to this. So this direction, remember, this direction isn't telling our character where to move. It's telling us which direction our character is moving in. This variable does not drive our character. And so right now there's a mismatch between the direction our character is moving in and the direction that our variable direction says that our character is moving in, because direction says 0, and well, our character is moving in direction 1. That's not a problem, because for this tick, direction is going to get set to 1. But before that mismatch is fixed for the tick, we set direction last tick to direction, which is 0. Now direction gets set, it's 1, but while direction is 1, direction last tick is 0, and we do it again. Direction last tick gets set to 1, while the direction, let's say, is something like 90. Okay, so now direction last tick is 1 and direction is 90. So that's how this works. And it's a super easy way of getting the value of the previous tick for anything that you're setting on a tick by tick basis. But the direction will still get set to 0 when we stop, and for one tick, direction will be what it was the previous tick, but then it'll get set to 0 too. And so our character will still unrotate, and we haven't solved that yet. What we want to do is we want to say when our velocity is equal to 0, when that is true, so we're using a branch, and that it's true, we want to set our direction to direction last tick. Having trouble connecting these. Okay, there we go. But if it is false, we want to calculate our direction, because that means the character's still moving around. So we plug into here. And now from set direction last tick, we're going to plug into our branch And so, okay, we set our direction for the last tick. Then we check, have we stopped? Yes. Set direction to direction last tick. Are we still going? Continue to get our direction and set our direction variable with it. And now, when we stop and we're using orientation warping, we're still being warped in that idle pose, which is what we want. But now, well, not but now, but always, when we're standing still and we turn our mouse, our character rotates in a very unrealistic manner. And the first step to fixing that is to get the character not to rotate with the mouse when we stop. And we're going to do that by using a rotate root bone node. So I'm going straight into our grounded state, and before our power IK ground, because let me show you what happens if we put it after our power IK ground. And I haven't actually tried this, so watch, maybe I'll be completely wrong about this, but I believe that this rotate root bone, unless Unreal Engine has some back-end extra programming to save you from these kinds of errors, which I don't think it would. I'm just de-exposing these two, we only need yaw. We're figuring out our feet positions for the ground, but then we're rotating our root bone and we're not refiguring out our feet positions after that. So our root bone is rotated, and yep, see, our character does not line up. So we want to rotate our root bone before we do our ground alignment. So now what are we going to rotate our root bone with? We're going to rotate our root bone with a root yaw offset variable that we're going to create. And so there's a moment to show you guys a newer feature that Unreal Engine has. If I do root yaw offset, and there are multiple cases where I could have done this previously, but I'm only really just thought about it now. So we have this float, our root yaw offset. We could just do that. That's a possibility. That's how it has been done by Unreal Engine users for years. Or we could change it from exposed as pin to root yaw offset. And there. And that's just another way of doing things. It makes no difference really, and it's just a matter of personal preference. So now we need to calculate our root yaw offset. And we're going to do that. So I'm going to do another little demonstration here. We turn our camera, our character turns. So it makes sense to just say, okay, how far have we turned our camera? And we're going to unrotate the character by that. We could actually get the control rotation directly, multiply that by -1, and plug that back in. But that's not taking into account the direction that the character is moving in, or well, facing, or was facing when we were moving. So we're facing at about 360 for our control rotation. Well, now it's going to unrotate the character back to face forward when we stop, and that's not what we want. So we want to get the change in control rotation frame by frame, and we want to add that up from when we stop so that it unrotates the character by the amount that we have rotated the camera since we've stopped, and not the amount that the character is rotated in total. And so we're going to do something very similar to what we did with direction, and we're going to get control. We actually have to get a reference to our character, and then from that we can get control rotation. I'm just going to get a break rotator node, and yaw is what we're looking for. So we have our yaw, and we are going to set a variable with it. And we're going to promote this to a variable. We're going to name it yaw. And we're going to duplicate this yaw variable. And we're going to make a yaw last tick variable. Now we can set yaw last tick before we set yaw, and we set it with yaw. So this is a very useful thing. We've used it twice in this one video. Now, I'm going to take this, and I don't have an extra pin in this sequence. I'm going to create one. I'm going to plug in this set yaw last stick to it. And now, we're going to reuse more code from over here with this branch. We're going to just copy this branch. Velocity equals 0 as the condition. So we're copying all of that and we're plugging that in after yaw. And this branch is saying once we've come to a complete stop, because moving around and we're stopping, I can still rotate the character around. We're stopping, I rotate it around. Stopping again, I rotate it around. And if I just use our stopped variable, I rotate it around real fast like that and it breaks it. So we want to just do what's next, where we actually set the root yaw offset when we've come to a complete stop. So if this is false and if we have not stopped, we want to set the root yaw offset to 0. Now, if this is true, we want to set the root yaw offset to the change over frame added frame by frame of yaw last tick and yaw. So we want to take the difference between yaw last tick and yaw and add that to a variable, our root yaw offset. So let's get our yaw. Let's get our yaw last tick. We're going to drag out from yaw last tick. We're going to get a float minus float node. We're going to plug yaw into the bottom pin. And we are going to take the result of this, the difference between yaw last tick and yaw, and we're going to add it with a float plus float node to root yaw offset. And now this is used to set root yaw offset. And now, if I click play, as you can see, we can rotate the camera around, and the character stays in the position as we rotate the camera after we move. And so the jump facing another direction we start is real fast, but that is not our concern right now. And so that concludes this first video in our 2 or 3 part, I think it's just going to be 2-part, rotating in place section of our distance matching series. Alright everyone, I hope you enjoyed the video, and if you did, please leave a like and subscribe to the channel, hit that notification bell too, and I'll see you all in the next video.